Hello, welcome to Sweden, country of cold winters, long beautiful summers, high technology and very friendly English-speaking people. Welcome to Stockholm, a sophisticated international city with a vibrant and diverse environment. Safe and clean, multicultural European capital with easy and quick access to city, to campus and to beautiful nature. And welcome to KTH, in English Royal Institute of Technology, where science, vetenskap in Swedish, meets art, konst in Swedish, and where you can study nuclear engineering. Let me introduce myself. My name is Wacław Gudowski. I am professor in reactor physics and program director of the master program in nuclear energy engineering. I shall guide you through our exciting master program in nuclear energy engineering. Once you come to KTH, I shall also guide you through the history of nuclear power. It is my big interest and my big hobby. Why to study nuclear engineering, you can ask yourself. Well, because it is a matter of hopes, of promising technology, but also a matter of misperception, public fears and concern. Because it is a matter of solving one of the most important challenges for our future, energy supply for a growing number of people on the planet. It is also, unfortunately, a battlefield for politicians in many countries. And last but not least, being pragmatic, there is also a good labor market in many countries. So, nuclear power, yes please, or nuclear power, no, thank you. Well, once more, welcome to KTH. KTH is a home of the Swedish nuclear power and also the place of stormy development of nuclear scattering physics in 50s and 60s of the last century. The first nuclear reactor was actually placed at KTH campus, 25 meters under the ground, went critical over 60 years ago at 6:00 p.m., July 13, 1954. The newspaper reported 20 men fission uranium. Swedish atomic reactor started in 2 days. Those were the days. The master program in nuclear energy engineering, as we call it TNEEM at KTH, started in 2007 and was the first nuclear energy engineering master in Europe taught in English in non-Anglo-Saxon country. Every year, about 25 to 30 students are typically admitted. Studies are tuition-free for Swedish and European students, but non-European students are obliged to pay tuition fee of about 150,000 Swedish crowns per year. Program is particularly popular for Swedish, French, Polish, Spanish, Chinese and Indian students. Well, I am proud to say that our master program is one of the 5 best KTH master programs as evaluated by the Swedish University Board in year 2012 and 2013. We do promote students' mobility, offering them many different options. Dual diploma program with a number of European universities in France, Italy, Spain, and Switzerland. Dual diploma master program with Tsinghua University in Beijing and with Korean Advanced Institute of Science and Technology, so-called KAIST. KTH is also a partner in the European Master Program in Innovative Nuclear Energy, so-called EMINE. I shall describe it a bit more later. One semester mobility is also possible in the frame of the European Erasmus program and in the worldwide mobility options with different universities. Politecnica di Torino in Italy, Technical University in Barcelona, Tsinghua University in Beijing, Korean Advanced Institute of Science and Technology, Harbin Engineering University, Kyoto University, Shanghai Jiaotong University, University of Illinois Urbana-Champaign, Idaho State University, and some more. The master program in nuclear energy engineering is given jointly by Department of Physics at School of Science at KTH and by School of Industrial Engineering and Management, as you can see on this slide. KTH applies European Credit Transfer and Accumulation, so-called ECTS system, which is a standard for comparing the study attainment and performance of students of higher education across the European Union and other collaborating European countries. ECTS implies both credits and grades. Well, how we count it? One study year of the student corresponds to about 1,500 to about 1,800 working hours and gives 60 ECTS credits. Consequently, one ECTS credit corresponds to about 25 to 30 hours of total student work, including lectures, laboratory exercises, home assignments, and library or internet studies. ECTS is also compulsory as grading system in KTH. However, some of the courses, including master thesis grade, use only passed or failed grades. Other courses are using scale from 7, excellent, to 1, failed. You can see that on the table. Master in Nuclear Energy Engineering corresponds to 120 ECTS and in 2-year study. There are 3 blocks of the courses over the 2-year study. Mandatory courses, and you can see here on the picture, which correspond to 48 ECTS credits. And in elective blocks, we have 42 ECTS credits, which must be selected out of over many courses, summing up to over 130 ECTS. Look what a fantastic choice have our students. For each course to be taken, there are statistically almost 4 courses to choose from. As one can see, mandatory courses are concentrated in the first year of the studies in order to give students solid grounds in nuclear engineering. In the second year, mandatory courses are focused on sustainability and more non-technical issues like methodology in science and methodology in physics. Elective courses. Look what a fantastic choice have our students, with all possibilities to design our own educational expertise. From future generation 4 reactors, transmutation of nuclear waste, to deepening reactor simulation abilities and or to specialize the management skill. For students willing to jump into fusion technology, there are also some courses to be offered, like plasma physics and experimental fusion plasma physics. See video pitches for each course for easier choices and navigation through the program. Pay attention. Each course has its KTH code like SH2600, SX2704 or MJ2405. For motivated students who want to take some elective courses beyond the standard list, we have so-called external courses, which can be selected on the same way as elective courses. Study supervisors help very gladly to tailor properly study programs. External courses are thought to be an offer for research-oriented students who would like to continue after their master studies with PhD studies and research work. There are some very unique features of our master program, like compact reactor simulator at KTH, advanced power plant simulator, APROS, so-called APROS project, reactor laboratory exercises at rear reactors at CEA Saclay in Paris. The experimental reactor ISIS is used there. A lot of laboratory exercises and individual projects. There is also visible emphasis in our courses on nuclear power safety, nuclear fuel cycle, and next future generation of nuclear power, so-called generation 4 reactors. Unique courses on safety leadership in nuclear power industry, promoting safety first principle and culture, and on geological storage of the spent nuclear fuel in Oskarshamn community are real exception worldwide. We do also a lot of field studies to reactor fuel manufacturing companies, to reactors, and to other industrial facilities. Diploma work, it is called also degree project, can easily be done outside of KTH after an approval from study supervisor or program director. Diploma work is a 6-month project of 30 ECTS at the last semester of the studies. In many cases, diploma work is in a form of industrial internship finished with Master of Science thesis. The diploma work, master thesis, must be obligatory presented both in written and orally in front of a KTH evaluation committee. Our master program is a part of the KTH's energy platform and InnoEnergy program. We are members of the European Master in Innovative Nuclear Energy, short name EMINE. Look at the web page here. The principle is very simple. Students are enrolled at the year 1 to either KTH or Technical University of Barcelona. And for the second year, students have a choice to continue either one of 6 nuclear tracks in Paris ENSTA, a consortium of Paris University and CEA, or to specialize in materials for nuclear technology at Institute of Technology in Grenoble, INP Grenoble. Then there are a lot of common activities for all EMINE students, like summer programs in energy management here, and summer program on materials. Dual diploma program in nuclear energy with China, KTH, Tsinghua University agreement. This is based on 1-year study at KTH and 1 year at Tsinghua University. We have the same diploma agreement with KAIST in Republic of Korea. So you can see a symbol here of cooperation with KTH and Tsinghua University, and here with Korean Advanced Institute of Science and Technology. We have a very impressive record of Master of Science thesis in the year 2010-2015. 23 master theses in 2010-2011 and above 35 master theses in last 3 years, and more are to come. Master theses are covering very broad range from nuclear power safety to accelerator-driven system for transmutation and accident-tolerant fuel. Internship and master theses at industrial partners like CEL, Électricité de France, Areva, Vattenfall, Westinghouse are possible. We are also very proud that over 80% of Eklund's prizes for Masters of Science theses were won by our master students. It's 25,000 crowns, not that little. Since early 2000, Eklund's prize is a Swedish national prize for best thesis in nuclear technology area. Prize is honoring Sigvard Eklund, a nuclear power pioneer in Sweden and the first Director General of the International Atomic Energy Agency. We do not avoid difficult subjects like Fukushima, Chernobyl or Three Mile Island accident. Nuclear power safety is our core interest. Here you can see actually lectures just on the Fukushima accident.
Now extended maybe to 60 years, some of them. So sooner or later it will happen.
We do a lot of study visits. Here on the picture you can see our former student visiting the simulator facility at Qinshan nuclear power plant in China. And yes, China saying definitely nuclear power, yes, please. Believe it or not, this is a comment from one of our French diploma students. She wrote, "I shall always remember KTH as the most student-friendly university of the world." At the bottom of the slide you have the references. Master in Nuclear Energy Engineering is also an excellent entry gate into research field like development of new reactor types, new nuclear fuels, new coolants, new approaches to nuclear power safety. One can also jump into neutron physics and neutron scattering physics. Remember, European Spallation Source, ESS, is under construction now in Lund, in Sweden, and in about 2020 it will start its operation. There will be a lot of neutron physicists needed for this facility. Fusion energy is also an option. After all, that's neutrons which carry out energy from the fusion. So everything you learn about neutrons will be also very useful in fusion technology. Last but not least, you can also continue the studies in nuclear physics and similar. So if any questions, please contact me. My email address is wacław@kth.se, the Department of Reactor Physics, KTH, Alba Nova University Center, 10691 Stockholm. And as you see on the left-hand side, we fly high. Thank you for your attention.